Okay, this is your video for my mistake. Here we start. This is section 2.2 in your textbook on operations with rational numbers in decimal form. So the expectation we have here is that the adding and subtracting rational numbers in decimal form should be something you could do without a calculator. And multiplying and dividing rational numbers in decimal form should be something you could do estimating without a calculator, and then with a calculator you can do the calculation. So question 4 is all about deciding what is the answer to this question. So in estimation, what we're going to do here is we're going to create, well, so if we estimate, we're going to use, we're going to round our answers to the nearest whole number or the nearest applicable number. So this particular one here is going to be positive 1. And to that, we are going to make this roughly negative 3. And our estimation is going to be approximately equal to negative 2. All right? So that's our estimation. When we calculate it, what I always ask you is, what do I have more of when I add them? More positives or more negatives? The answer for this is more negatives. And how many more will be the difference between the number of negatives and the number of positives? So I'm going to take the one I have more of, in this case negatives, and I'm going to subtract the one I have less of, which is the positives, to determine how many more negatives I really have. 1 take away 8 I can't do, so I borrow. 11 take away 8 is 3. 8 take away 9 I can't do it, so I'm going to borrow again. And 18 take away 9 is 9. And 1 take away nothing is 1. So when I use my basic algorithm for subtraction, I get 1.93. And again, that tells me how many more negatives I have. So therefore, our calculation will be negative 1.93. Oh, that's the wrong one. That's my calculation. Any questions on that first one? Question number B is easy because it's 5.46 take away 3.16. So when I estimate, it's going to be 5 take away 3, which is an estimation of approximately 2. And this one I don't need to think, what do I have more of, because I really have enough positives to simply subtract them. And my calculation, so my estimation is this, my calculation will be a positive 2.30 or just positive 2.3. In question C, I have a negative 4.23, take or adding to that a negative 5.75. So estimating, I'm going to use these as my estimations, which is approximately equal to negative 10 as an estimation. All right, my calculation, I'm adding together negatives to negatives. What do I have more of, positive negatives? I don't. I just have negatives. And the sum of those two, all I have to do is line up my decimals to figure out how many total negatives I have. 8, 9, 9. So therefore my calculation is negative 9.98. And finally, the last question, question D. I have negative 1.49, so estimating I'm going to make it negative 1, take away negative 7. Now if you want, you can contextualize that, saying negative 1 take away negative 7 is going to be a positive 6, or you can keep flip change to get an estimation of approximately positive 6. Now for my calculation, I'm actually going to use adding of the opposite to determine what do I have more of, positives or negatives. In this case, I have more positives. How many more I have, I'm going to determine that by subtracting. How many more positives do I have than negatives? Therefore, I have 5.34 more positives. So my calculation will be positive 5.34. Question 6 says estimate then calculate. So the estimation will be a positive 3 multiplied by a negative 3, which will be an estimation of approximately negative 9. For a calculation, we don't have to bother with the whole line up the decimals or drop the decimals and use your estimation. We're just going to use a calculator, because in the real world, you all have phones on you all the time. My calculator, there it goes. Wow, it's a big calculator. So 2.7 multiplied by 3.2 equals, since we're 8.64 is the product, and since we're multiplying a positive by a negative, we know the calculation, since it's a positive times a negative, is going to be a negative 8.64. Going real quick with the rest of them, D, we're going to use negative 3 divided by positive 3. And we're going to say our estimation is approximately equal to negative 1. Our calculation, if we take our calculator here, 3.25 divided by, that's a good idea, 2.5 equals 1.3. So our calculation is going to be, I just closed it, yeah, oh well, negative 1.3. C, my estimation will be negative 6 times negative 6, which is going to be a positive 36 estimated. My calculation, 5.5 times 5.5 equals 30.25. Calculation is 30.25. And finally, your last one, D, for my estimation, negative 4 divided by negative 1, our estimation will be approximately positive 4. My calculation will be 4.37 divided by 0.95. Now, because I'm dividing a negative by a negative, I know my answer is going to be positive. And the answer is, I don't know if this is going to work, though. It's not going to work. And my answer will be 4.6. Now, for question 8, we do have bed mass questions. So in order to do this, what you first need to do is write down the question. And then using order of operations, determine what you're going to do first. So in this particular question, I have a multiplication, an addition, and a multiplication. So because we have three operations, we're going to do multiplication first. Now you can do one of two things. You can solve multiplications independently of each other and rewrite one at a time. Or if you're really clever, you're just going to write the multiplications, do them all at once. All right, so the first one, when I multiply those two, I know that my answer is going to be negative, right, because of sign rules. Negative 2.1. So I'm going to put 2.1 multiplied by 3.2, and that equals negative 6.72, and then I'm going to put the plus sign down. And now I'm going to do my other multiplication, which is 4.3 multiplied by 1.5. And since I'm multiplying a positive by a negative, this is going to be a negative 6.45. So my next line of my bed mass is that, and then I'm just going to add those two together, negative 6.72. If you want to put the positive negative button, you can, plus a negative 6.45 equals negative 13.17. Question B says negative 3.5 multiplied by the difference between 4.8 and 5.6, or 4.8 take away 5.6. So according to BedMath, we're going to do our brackets first. Now, because you're allowed to use a calculator, 4.8 take away 5.6. I know it's going to be less than 0. It's going to be negative. It's negative 0.8. So when I write this down, I'm going to put negative 3.5 multiplied by negative 0.8. That's my first step in my bed math. And my second is to multiply that negative 0.8 multiplied by negative 3.5. And I'm going to put the negative symbol in. And the answer is going to be a positive 2.8. And finally, C is negative 1.1 square bracket 2.3 take away round bracket negative 0.5 end round bracket end square bracket. And Donnie asked the question, why are there different brackets here? Well, because inside this bracket, the square brackets, we already have rounded brackets. So in order to differentiate between the rounded brackets and the square brackets, we use a square bracket and a round bracket. But it still means do this first before you do the multiplication. So negative 1.1 multiplied by whatever 2.3 take away negative 0.5 is. So I'm going to take my calculator right here. And I'm going to take 2.3, take away 0.05. No, that's not right. No, that's not right either. 0.5 negative equals 2.8 positives. And then I'm going to take that 2.8 and I'm going to multiply it by a negative 1.1. And that's going to give me a negative 3.08. Okay, any questions on that? Okay, for purposes of expediting, I'm just going to do question C for this one. So for this one, my operations in this particular question are, I have an addition, I have a multiplication that's in between those two, and I have a bracket with addition in it. Of those three, the first thing I'm actually going to do is my addition inside the brackets. So I'm going to keep this like this, and I'm going to solve the brackets. If I have $2.80 and I add to it $3 worth of 50 cents debt, the answer is going to be negative 0.7 when I subtract those, when I add those two together. Once you have the bracket simplified, you now have an addition and a multiplication. You're going to do your multiplication first. So I'm going to write down that addition. 1.2 times decimal 7 is 8.84, is that right? I'll take my calculator. Oh, heavens to Betsy. So 1.2 times 0.7 equals negative 0.84. And finally, I'm going to combine those two. And I don't want to use a calculator because I don't want to bring it up again without. So it's 5.2, negative 5.2. Question number 10. In Regina, Saskatchewan, the average mid-afternoon temperature in January is negative 12.6 degrees. The average mid-afternoon temperature in July is 26.1 degrees. How many degrees colder in Regina in January is Regina in January than July? So we're looking for the difference between the two. So if we take our first temperature on a thermometer, and we're just going to make a thermometer this way, and we'll put 0 here. And we put the high temperature over here. What we're really asking is how many degrees colder is it? So if we look at this as a picture, we know that we could just combine those two temperatures and we would have the number of differences. But since we're looking for the difference in temperature, the difference means subtraction. So if we look at the difference between those two temperatures, keep flip change, the answer would be 38.7 degrees, or negative 37.8 degrees, or in total, 38.7 degrees temperature difference between January and July. Question 11, one January day in Penticton, British Columbia, the temperature read negative 6.3 degrees Celsius at 10 and 1.4 at 3. What was the change in temperature? So this one, again, exact same question. Negative 6.3, positive 1.4 degrees Celsius. So again, if I find the difference between the high temperature and the low temperature, that will tell me the difference is 7.7 degrees in difference. That's your A. What was the change in temperature? Now the second part, B, is a little bit different because we're looking for the average change in temperature by hour, right? So between 10 o'clock and 3 p.m. So we got 11 a.m., 12 a.m., 1 a.m., 2 a.m., p.m., 3 p.m. We have 5 hours difference. So if we take the total change in temperature and divide it by the 5 hours that the temperature was changing and say what is a total of 7.7 degrees divided between the 5 hours. It tells me the average temperature change. Therefore, the average temperature change was 1.54 degrees Celsius per hour. Okay. Question 12. A pelican dives vertically from a height of 3.8 meters above water. Then it catches a fish 2.3 meters underwater. So if I was first doing this one, I would draw a picture, and the vertical distance is 3.8 meters. The fish is 2.3 meters underwater. So the picture to help me get, just like the number line was in the last question, this will help me get the understanding of what's going on here. Write an expression using rational numbers to represent the length of the pelican's dive. Well, the difference between his apex and where the fish is going to be the difference between 3.8 meters, the difference being subtraction, and negative 2.3 meters. That is an expression that represents the difference. Okay? And when I do that, keep flip change, I get 6.1 meters as my answer. Okay? So once I simplify it for B, the total distance of the pelican's dive was 6.1 meters. So therefore, the dive was 6.1 meters in total. And your question 13, which will be the last question we do, it says a submarine was cruising at a depth of 153 meters. So if I make the water here and my submarine is at a depth of 153 meters, or negative 153. It then rose at a rate of 4.5 or positive 4.5 meters for 15 minutes. So it's going to be 15 minutes or 15 groups of positive 4.5 meters. Each minute, it's going to raise 4.5 meters. What is the submarine's depth at the end of this rise? So the expression you need to start with, if I put it in word form, starting depth, starting point, plus change equals new point. If I think about what this means, my starting point, and I add to that the change in my depth, those two combined will equal where I'm at now, or my new point. So, if I translate that into numbers, the starting number is negative 153, my starting depth. And to that, I am going to add 15 groups or 15 minutes, 15 groups of raising 4.5 meters each of those. So 15 meters of raising 4.5 meters per minute. Okay, so a positive 14.5 or 4.5. So that right there is the expression that represents the submarine's new depth. Okay, now if I simplify that, I will know where it currently is. So I'm going to take my bed mass calculator, and I'm going to say, well, negative 153 plus 15 minutes of raising 4.5 meters each is going to be a total of going up 67.5 meters. I'm going to combine that with the original depth of 153 negatives. And that means the current depth of the submarine is 85.5 meters underwater. Okay? Now the important takeaway is that's the most important part, is being able to create that expression that represents the change in depth. That shows the most academic skill in that. After that, the simplifying to get the current debt is just an order of operations question. But the creation of that expression is the hardest part about this whole question. And your last part to that question, B, says if the submarine continues to rise at the same rate, right? How much longer will it take to reach the surface? Now, this is a hard question because what we're going to do here is we're going to solve this with algebra, okay? So here's what we're going to do. X is going to equal the number of minutes. All right? So X is going to equal the number of minutes because we're looking for how long will it take to reach the surface. So X is going to equal the number of minutes. So if we take the starting depth of 85.5 meters and we add to it how far it rises. So it's going to rise 4.5 meters multiplied by what? The number of minutes, correct? So since we have assigned X to be the number of minutes, our algebraic expression will be negative 85.5 meters, which is where it currently is, plus it raises 4.5 meters for every minute. So that's going to be 4.5 multiplied by X, the number of minutes. And that has to equal what number? This has to equal 0. Or, if I think about it in terms of a picture, it's at negative 85.5, and it raises 4.5 meters a minute. The question is how far until it gets to the surface, which is 0 meters at sea level. It's at sea level. Okay? So there's our question. So using algebra, going back to grade 8 for a second, which part of this equation is my constant? Negative 85.5 is my constant. That's my plus or minus value. How do I get rid of that constant? I'm going to add 85.5 to both sides. Constant's gone. Agreed? I now have an equation which is 4.5x, or 4.5 meters multiplied by the number of minutes, has to travel the distance to the surface, which is 85.5 meters. That makes sense now. That looks better. Now we're going to divide both sides by our coefficient to figure out how many minutes it takes to reach the surface. So if I'm 85.5 meters below the surface of the water, and each minute I raise 4.5 meters, if I divide those two, that's going to tell me how many minutes it takes me. I do have it open. So, Claire, 85.5 divided by 4.5 says 19. You with me? And my last statement is therefore, since X was defined as the number of minutes, and I have it here, my sentence is going to be therefore, it will take 19 minutes to reach the surface. Now, that's solving it using algebra, and I'll guarantee you not one person did use algebra, right? Right, you did it in your head. That's fine if you did it any other way but got 19, that's fine. No problem, great thing. But what I would like to show you is that it is possible to apply algebra to solve it the same way. And you all have basic algebra skills, and what I showed you there for algebra is not overly complex, is it? Right? But it's important that you see it so that maybe you can use it in the future.